Okay, so the name of this chapter is called Transitions, and it's called Transitions simply because we are going to spend most of this lesson reviewing, which is always a good thing. Most of chapter 7 is going to be review over what we've already done, and then in chapter 8 we'll start with the real thing. So this particular chapter is 8 lessons long, so not too terrible, but it'll be a couple weeks before we get done with it, so you can kind of relax and just be reminded of what we've done in the past during this section. Okay, so linear equations in one variable. If you look in the middle of 392, it talks about what a linear equation in one variable is. It sounds bigger than what it is, but it's actually a linear equation, which means it does not have any exponents on the variable. And, oops, I've got, let me fix my little mistake here. And let me keep that as a 5. Okay, that's a linear equation in one variable. There's one variable up there. It doesn't matter how many times that x appears up there, but it's only one letter that may show up several times, but it's only one letter, and the exponent on that letter is a 1, making it a line. So that's all a linear equation in one variable is. A solution set to this is what are all the answers that x can be? Is there only one possibility up there that x can be? Yeah, there is. But sometimes, and when we did this before last semester, sometimes x can be 2 numbers, 3 numbers, sometimes it's an infinite number of numbers. So if I put 3x equals what? Well, that what could be anything, right? Anything you put in for x, if you put a 1 in for x, you get 3. You put 2 in for x, you get a 6. There's an infinite number of answers. So that solution set's going to be huge. Okay, the second definition says 2 or more equations with the same solution set are called equivalent equations. So, that means if I say 2/3 x equals 12, or I say 4/6 x equals 12. Those are similar equations simply because this fraction and this fraction can be reduced, or the 4/6 can be reduced to 2/3, so it makes it the same equation. Okay? So they're called equivalent equations. They're going to equal the same thing. Okay? And they don't even have to look alike. Sometimes, I mean, if I were to say something like 3x equals 12 and 4x equals 12. Those are equivalent equations because they both equal the same thing. What does that tell me? It tells me that 3x and 4x are equal to each other in order for them to equal 12, right? So that's what makes them equivalent. If you look at the top of page 393, it gives you the multiplication property of equality. And pretty much, I mean, you guys use this all the time. For the most part, all it's saying is if 3 equals 6/2, then 3 times 2 is going to equal 6/2 times 2. As long as you multiply the same thing to both sides, they're still equal. That's all it's saying. And like I say, you guys have done this before. Nothing new there at all. In fact, I'm going to skip example 2 because you're already on top of it with that. Example 3 we'll skip. In fact, I think we can probably skip all these examples until, well, let's stop at example 6 on page 396. So, okay, is there anything difficult about that? What are you going to do first? What was that, Bree? Okay, remember our acronym? Remember that, PEMDAS? Okay, so given that, what are you going to do first? You're going to do what's in the parentheses. Can you do anything in parentheses, Bree? No. So the next step is exponents. There aren't any. Next step is multiplication. Is there any multiplication? Okay, the first multiplication, you start on the left-hand side and go to the right. And really what you're doing here is you're looking for any multiplication or division here from left to right. If division, if shows up first, do that. And then if you see multiplication, then do that. Just do it multiplication and or division from left to right. And what we have there is the 3 times 4x and then the 3 times the 2 in the parentheses as you distribute, and that's your multiplication. And then you'll just do your addition and or your subtraction and then solve for x. So it's just your typical using PEMDAS in order to solve for those. Page 397, the next section there is solve equations by factoring. And that's, again, not too long ago that you were doing that. And you had equations that looked like this: x squared minus 2x minus 24 equals 0. Do you remember how you did those? I know, it's been almost 3 weeks, hasn't it? Okay, so you've got your parentheses to use your factoring. And you've got your x and your x. 2 numbers multiplied to give you 24, added together give you 2. Okay, a 6 and a 4. And you're saying a plus 4 and a minus 6? Okay. Because negative 6 times positive 4 is negative 24. Negative 6 plus 4 is negative 2. So that will work. And then what is my answer? That's just factored. What's my answer?
X equals 6 or x equals 4.
Okay. So remember, when there's an equal sign there, they want you to solve for the variable. If I would have just given you x squared minus 2x minus 24 and just said factor, you would have left me with x minus 6 times x plus 4 because there's no equal sign. You cannot solve a problem without an equal sign. So, when you look at example 10, down there in the middle of page 398, we won't do that one, but what is the first thing you're going to do with that? Okay, so Gabe was suggesting factoring out an x because we have an x cubed, and you really haven't learned how to use those x cubes yet. So before we do that, though, let's get all the x's, let's get everything on one side at equal sign, set it equals 0. Then we'll pull the x out like Gabe said here. So 1/3 x cubed minus 5, 6, x squared minus 1/2 x equals 0. All right, so we pull that x out. Okay, so what is the part of that equation that is nasty about it? Is what? All of it? Yeah. The fractions.
You can simplify it by the least common denominator.
Okay, so what is the least common denominator?
6.
Okay, 6. So if we multiply that whole parentheses times 6, we're going to be able to make a change there and end up with 2x squared minus 5x minus 3 equals 0. We still have to have our x out here. Okay, so if I multiply this by 6, let me make it red here. If I multiply that by 6, that gives me my 2. And this by 6 gives me my 5 because these cancel. And this by 6 gives me my 3. So that's where it came from. And then it's going to be a lot easier to work with. And then as I continue to solve this, I've got my 2 parentheses. And when you do the math, which you guys already know how to do for these, you get 2x plus 1 and x minus 3. you remember how to get the 2x plus 1 and the x minus 3, Bree? You look like you're trying to remember.
No, why did you do 2?
Oh, I'm sorry. X. I don't know. I was thinking ahead of the 2x and just stuck a 2 on there. That's the confusion. All right, so how many answers do I have on this? The 2x plus 1 and the x minus 3. Okay, let's do that. All right, we take our first term and our last one and we multiply them and get negative 6. So I'm looking for two numbers multiplied together, give me negative 6. Added together, give me my negative 5 right here. Okay, so in this case it would be a 3 and a 2. 3 times 2 is negative 6, and 3 plus 2, you can get your negative 5. So then you end up rewriting it as 2x squared. What did they say it was, 3 and 2? Minus 3x minus.
Plus 1 doesn't equal.
Oh, I'm sorry, it should be 6 and 1. What am I thinking? Yeah, two numbers multiplied together give me negative 6, added together give me negative 5. So this would be a minus 6x minus, or plus 1. So those two numbers multiplied together, 6 and 1, give me my negative 6. Added together, give me my negative 5. So I put these two in place of my negative 5x. And then I'm able to do my grouping. Yeah, and then you factor out. So on this particular one, I factored a 2 out and had, a 2x out and had x minus 3. And on this one, I factored out a 1 and had x minus 3. So this became 2x plus 1, what was on the outside, and x minus 3, which was these two here together. And that is where that came from. Okay, kind of went a little fast, but that should be reviewed. So how many answers do I have? This right here tells you.
3.
Okay, and right here I've got an x here, I've got an x here, and I've got an x here. So I've got 3 different options for my x there. So what is one of my options for my x?
3.
Okay, because you are putting 3 in this, right? And getting 0. My option for x here is going to be negative 1/2, because I'm going to say 2x plus 1 equals 0 and solve for x there, and you get negative 1/2. Would you like me to do that, or? Okay, and what does this x have to be? 0, because I need a number when I multiply it by this, and this, that is going to give me 0. And the only one that's going to work is if I put a 0 in here. So 0 times anything, no matter what these are, is going to give me 0. Okay, I feel like I'm kind of going a little fast with this, and I don't want you guys with 2 or 3 weeks of not doing math under your belt to be like, I am so confused, I don't remember my life before Christmas. So holler at me if I'm kind of out of control here, but I don't want to insult your intelligence and keep doing stuff that you already know how to do either. So I think I want to do more green. I like this because I have a lot more choices for colors than I did with the other one. All right, so what are you going to do when you have something like x minus 2 and x plus 1 equals 4? Are we solving for x? Sure we are. There's an equal sign. So this is a little bit backwards, because before what you were doing to solve for x is you were using the FOIL method. Now in order to solve for x, you're going you factored. Now what you're going to do is the FOIL method. So when you do the FOIL method, you're going to get x squared minus x minus 2 equals 4 when you multiply those out. Why couldn't I just look at these and say, oh, cool, x is 2, x is negative 1, and be done? What's keeping me from doing that, Shania?
Well, is it supposed to be negative 2x since you or am I wrong?
Oh, when I do FOIL?
Yeah. Or am I going,
If I do FOIL, I do my first,
yeah.
and I get x squared. I do my outside, so plus 1x. Do my inside, negative 2x, and then my last, minus 2. And these two together give me a negative 1x.
Okay.
Okay? No, don't question me, hun, because how many times have you seen me make mistakes? So I used to take offense at that back in my early years when I was really full of myself. I don't anymore. I realize I'm going to make mistakes, and I need students to keep watching up there to correct me when I do. So, no, never a problem. But again, why is it that I can't say x equals 2 or x equals negative 1 like I did before? Because it's not equal to 0. If this were 0, I could do that. The only time I can do it. But because it's a 4, all I'm going to do is the FOIL method. Bring this 4 over, set it equal to 0, and factor it back so it looks like this again, but it's equal to 0. So, I've got x squared minus x minus 2 minus 4 equals 0. So now I'm down to a trinomial that is set equal to 0. Now I can factor it down. Okay, so that's the only thing I did here. Is I really like this cool little laser thing. All I did is foiled it simply to get this to be a 0 so that I could factor it again and end up with an x here, and it's going to be a 3 and a 2 this time. So it's going to be a negative 3, a plus 2. Now I can say that x equals 3 or negative 2. So yes, that was good, Shania. Remember, this has to be a 0 before you will be able to get anything by factoring. Okay. When you have a problem, like, what time is it?
Like 2 minutes.
Okay. Keep seeing you guys looking at the clock, and I'm wondering if I'm... When I have one like that, what do you do with that? I'm solving for x, but now I've got 4 terms, and I got some variables that are a little bit bigger. You know, the 3 up there. Okay, when you're given 4 terms like that, what I would suggest doing is grouping. Throw those two together like that. Then, like on this one here, I can pull out an x squared and be left with an x plus 2. I can pull out a negative 9 and be left with x plus 2. See how I have an x plus 2 left when I pulled that 9 out? One of the things, again, to remember when you're doing that, when you're pulling things out like this 9, make sure that you redistribute it to see if you're going to get this back again. So negative 9 times x, yeah, it's negative 9x. Negative 9 times 2, it's negative 18. So it works. Make sure that you check your signs, because I blow that all the time. And then you've got x squared minus 9 times x plus 2. But because of this right here, this 2 here, I know that this is a difference of 2 squares, and I can keep going here. And then add my x plus 2 there. And then at this point, because up here, I figured out I had 3 answers because of this 3. Well, this gives me 3 parentheses. So my x is 3, negative 3, and negative 2. Okay. So again, I apologize if I went too fast and your head's spinning, but I think it'll all start coming back to you pretty quickly. I don't know what the lesson is. You'll see it on the internet. I think it's 1 to 81 every other odd, but I don't know for absolute sure.